Hello, ladies and gentlemen, good afternoon. You're watching the meetup on what do companies get out of quantum projects today. My name is Koen Groenland. I am Quantum Innovation Officer at QuSoft, and I'm also working for Quantum.Amsterdam as the community manager. But the real stars of today are sitting right next to me. So let's introduce them. First of all, we have Victoria Lipinska. She's working for KPN as Quantum Advisor. So Victoria, a warm welcome.
Yes, thank you very much. I'm very happy to be here and thank you for organizing this event. Like you said, my name is Victoria Lipinska. I'm a quantum advisor at KPN, and my job is to take care of the quantum end of all of the quantum projects. That relates mostly to quantum communication, since KPN is a telecommunication company. And my background is in quantum communication and cryptography, actually, so pretty close to what I'm doing right now. And I finished my PhD at QuTech in the group of Stephanie Wenger.
Excellent. Thanks a lot, Victoria. We'll hear a little more about the KPN project in a little bit. But let me first introduce Dimitri van Esch, the quantum lead at the ABN AMRO Bank. Well, welcome.
Thank you, Koen. Nice to be here. Nice to be here in person and trying out this hybrid situation where we are being together, but others are not. So ABN AMRO started working in ABN AMRO in 2018. And my job was to scout new technologies as far ahead in the future as you can envision. So quantum technologies is far-fetched. So we started searching for that, exploring projects. So we started the quantum program by the end of 2018. I'm also doing solution architect work at the bank, translating business to IT, because we have other things besides quantum that we do at the group innovation. It's also fun to do. And my background is IT. Started doing almost everything within IT except design, so don't ask me to draw a picture. Other than that, I can fix everything you want. And I've also did some project management, business development, and I've been a CTO at several startups before I joined the bank.
Excellent, thanks, and welcome, Dimitri. Now, before we start, let me take a moment to ask the audience what your background is. So as you may see, if you're watching live below this video on the Quantum.Amsterdam website, you will see a little app called Slido. You can use that to ask questions, and please do that. Then I can refer them to our guests. But also I want to throw a little poll at you, which is the following. What is your professional background? So do you perhaps work at a company, maybe for a government or NGO? Do you work at a university or institute as either a scientist or support staff? Maybe you're a student, and maybe you're self-employed. Maybe you don't recognize yourself in one of these. Maybe you have a startup. So please let me know, and we'll get back to these in just a minute. So, well, let's start with KPN's project. You said that you're leading these quantum projects. Can you tell me What exactly do you do?
Yeah, so quantum is oriented into, let's say, two pillars at KPN. And the reason for that is because quantum technologies are still far ahead in the future. So somehow we were trying to divide everything that we can do for the future into timelines. And so it happens that the first one of those, so that the closest technology that we can reach is actually quantum key distribution, known as QKD. So that's our first goal, first objective to reach, and then expand that quantum key distribution network to actual quantum internet that would luckily and hopefully have more applications. So when it comes to the first area, so this...
Maybe can you tell a little bit, what is the difference between a QKD network and a quantum internet?
Yes, I will get to that in just a second. So in the first area, what we focus on is, like I said, quantum key distribution. What this does is basically distribute keys among two users of the network in a completely secure way. So naturally, the application of such a network is for security mostly. Now, when it comes to quantum internet, we actually rely on those very quantum connections, quantum links between 2 points. So that means that actually to maintain that and to create such a connection is a lot harder. And therefore, we need more advanced technology, more advanced setups to actually achieve this. And therefore, the quantum internet is something that will come later on in the future. But the first step to achieve this, like I said, is the quantum key distribution network.
Excellent. So what sort of project do you dare then? Because there's no quantum key distribution network yet, right?
No, absolutely not. But what is important already right now is to try and implement those mini networks on a demonstration level to really see how they would work with the KPN network, or in general with a telecom network. So first of all, what we did in July, we held a demo for measurement device independent quantum key distribution. It's a mouthful, but what it basically is, it's a way to distribute this key between two users, like I said, and we did that between Delft and The Hague. So one of the users was Delft, one of them was in The Hague, and we had a central node that was connecting those two and served as a sort of intermediate measurement to actually perform this key distribution. So we did that. This was in collaboration with QuTech and Quantum Delta and Cisco. This was a very successful demo. We actually were very happy to host that, not only the devices for the MDI QKD, but also the event itself. And if somebody wants to watch, this is still available to stream on YouTube. So you just have to type MDI QKD demo.
You're the top MDI QKD video.
I should hope so. But
right.
and then another thing that we're doing right now, also in collaboration with QuTech, but also TNO and other partners like OPNT and SURF, we're actually trying to establish on the same link, Delft The Hague, we're trying to establish a real quantum connection. So that means that we're trying to create entanglement in order to later on measure the quality of it and perhaps perform some other more sophisticated applications than just QKD.
So that's the core difference between QKD and the internet, right? So QKD,
Absolutely,
you
yes.
just get the keys out, but no entanglement?
This is the only functionality that you can get out of QKD to actually get a random string on both sides. And then what you use that for, that's kind of on you. And with quantum internet, you really want to create a quantum link to be able to perform connection to the cloud, for example, the quantum cloud, or more sophisticated applications like teleportation.
That sounds very cool and futuristic. We'll talk a lot more about that in a second. Let me first return to the poll that we just had. We asked you, what is your professional background? And I see that by far most people actually work either at a company or at universities, which is beautiful because Quantum.Amsterdam is essentially about connecting these. I would honestly hope that in the future we get more startups in here as well, actually. I hope that these will sort of participate in this quantum ecosystem. So let me turn off the poll. There'll be more in a bit, but first let's turn to Dimitri. So with ABN AMRO Bank as quantum lead, you had several projects. Can you tell us about them?
Yeah, so we started actually with one project together with KPN. That was the pre-Victoria times, where Jay Baloo was still the CISO, where KPN and ABN AMRO brought in a use case to explore business cases for satellite QKD systems. And we had a pretty good use case. And the same use case we also placed into a project that we're doing now together with QuTech and TNO, which is called Secure, which is kind of like the same that Victoria did with the MDI QKD network. But the difference is that in our system, we use one fiber link and one free space link. And they're telling me that it's way harder to do that because all kinds of synchronization of frequencies, whatever. But we're nearing the end of this. It is about to end this year, end of this year. And then we demonstrate that we can use a financial application. So we have a full application running using those keys from the system. One other project that we're doing is called DisQover. We're going to talk more about DisQover now. Okay, Victoria is the QKD part of this session right now. So I'm the, let's say, algorithm part. Because we also see, algorithms are also an important part of quantum. And most people are talking about quantum computing, but it's more than that. But, the algorithms are also a nice thing to do. So we started 2 years ago also together with QuSoft, exploring quantum algorithms to see where we can find advantages in using those algorithms or applications to do computational tasks.
So how do you do that? How do you find these advantages?
That's very hard. The thing is, when I first learned about quantum computing, I went to IBM Think. I saw IBM presentations on quantum computing. And when you start that, then you start thinking, okay, so quantum computing is the solution for everything, and it can solve everything, and it can make everything faster. But it's not. Quantum computing will only be applicable at very, very small number of applications, and even those applications at this moment will have, let's say, a limited speed up, and it's very hard to get to the right speed up, and besides that, it's very hard to look at your data. What kind of data do you have? How can we transform it into a quantum algorithm? And then if you get it into an algorithm, how can you run the algorithm? And then if you run the algorithm, what can you do with the results? Because it's not that obvious to have quantum results and take them into your classical world and use them to a certain extent. So it takes a lot of time. And we explored it from a use case perspective. So we looked at more than 80 data science use cases within the bank. So we have a list.
80,
80, yeah. So we have a list of a lot of use cases that we want to explore and already are exploring within the bank. So we have different teams, different data scientist teams looking from all different kinds of angles. So for instance, Monte Carlo simulations, but also in the fields of fraud, but also in fields of security, and also in the fields, for instance, in anti-money laundering. So they also have different data sets, different views, and so we took all of those use cases, explored them, and where we thought there might be a quantum speed-up potential, then we took them out and worked them out in more detail.
Can you already give a bit of a spoiler? We've always been looking for this killer application, right? And you checked 80 different cases.
Yeah.
Did you find a killer application?
No. No, we
so that means a failed project, right?
If you call it depends what you call a killer application, right? If you're asking me, did we find the next source algorithm? No. Did we find algorithms where you can have a speed up? Yes. Do we know exactly what the speed up will be? Almost. We're still working out the details, and the devil is in the details. And the thing is, and maybe we can talk about it later, but the thing is, if you really want to, let's say, compare a quantum algorithm with a classical equivalent of that, you need to know how fast all the steps are in between and all the hardware is in between. And for, let's say, classical algorithm, you kind of can compute that, some benchmarks, the speed of the individual functions. But for quantum algorithms, we don't know yet. We don't know the speed of a Grover function in quantum. And that can be different on each quantum computer that you're using.
So you want to know how it works if you incorporate everything together, the quantum part, the classical parts.
Yeah, and then it's also use case dependent, because at some point you need to break down your data into certain parts, somehow put it into a quantum computer. So you have kind of a hybrid situation where if you compute the whole system, you're still missing out things, or and we have even saw that in some cases we couldn't read the results. So great algorithm, can't see the results, so you can't use it. Or use cases where you need QRAM, and liking the quantum internet, which is far fast. I think QRAM is also even further ahead in the future than the first quantum computers.
All right, thanks a lot, Dimitri. So we have two very interesting projects. ABN AMRO looking at, I guess, software, how they could possibly use quantum software. KPN looking at quantum key distribution and a quantum internet. I guess it makes sense, right, that a telco provider also likes to provide a quantum internet, but we're far from there yet, I think, right? There will be, I guess, many, many years until you can actually earn money with that. So let me ask you a very bold question. Why is KPN putting money in this? Why don't you just wait until scientists figure this out? Because I'm sure these projects will be pretty costly.
Absolutely, yeah, that's an excellent question, because obviously we can ask, why not wait, right? We could wait for everybody else to start implementing that and just then in 10, 20 years be like, hey, okay, this is a new thing that we also want to implement, so how do we do that? But then we actually arrive to the question, how do we do that? And this question is something that if we want to be strong on the security side, this is has always been one of the KPN's very, very big objectives, to really bring security to the end users of the network. And if we want to keep doing that, we already have to start looking on how to implement this so that in 10, 20 years, we are not delayed with questions like how, but we already know how. Okay, and so we can bring the best service to the customers.
So you need to take steps now in order to do something in 15 years?
Absolutely, because this is a process. This takes time. Changing the network accordingly to what, quantum key distribution or quantum internet will require. That takes time. Planning all of the layers of the network, making sure that the classical internet, the normal internet, and the quantum internet actually talk to each other, that these are not two disconnected systems. Making all these changes will really take a long time. And the time to start actually is right now, because if we don't do it now, we'll simply miss that ship.
Okay, so you said about 15, 20 years. Is that when you expect that the quantum internet will be available for end users, for companies that pay a little bit extra in their subscription?
That's my guesstimate, I would say. And that guesstimate is based on the fact that we're somehow predicting in the field that the quantum computers will be available in maybe 20 years, if we're lucky. And then actually, if our quantum internet is at the point that we're able to create not only entanglement, but to maintain it and actually handle it in the network in a consistent way, then we can provide this connection to the quantum computer as a service. So this is something that what I said before, it's a quantum computing in the cloud. And quantum computing in the cloud actually has a lot of potential users, because it's not only banking, but it's also pharmaceuticals. So another application of quantum computing, which is simulation. And there is a lot of predictions that, for example, by McKinsey, that there will be a lot of funding put into quantum computing because of that reason, because people will want to use it for simulation. And then, okay, it will still be, I actually expect that we will all be dead by the time we have a quantum computer at home. So then there is a question of how do people use it? Right? How do big companies use it? Well, by connecting to it remotely to the cloud. And that connection is something that once quantum computers are there, we could be able to provide. That's why we have to start right now.
Okay, so what would you ideally get out of this project then? Is it mainly focused on pushing the technology further?
Yes. So that's one of the objectives, but also really to be part of that ecosystem, the Dutch ecosystem, to create a test bed, a network, which we could actually develop together. Yes. So this is part of the objectives of the Quantum Delta NL actually.
Okay.
This is a very important. Yeah, maybe we can talk about this later, but this is a very important part and very important step of actually pushing the development forward.
Yeah, so some people, at least the Dutch, like to claim that we have sort of the best prototype quantum internet in the world. Is that true?
Of course.
Yeah, I think so.
Well,
of course, you're from KPN, so
of course I have to say that, right? But let's not forget that there are other giants in the world, like China, who demonstrated a network of 4,600 kilometers. So that's over 4,500 kilometers network of QKD, quantum key distribution. That's massive. We don't have that quite yet, but nevertheless, the developments when it comes to quantum internet and actually having those quantum connections is quite strong.
So shouldn't I say that China is way ahead of us? Because if we can connect Rotterdam and The Hague, what's the distance between these cities?
Rotterdam and The Hague, I don't know, that would be around 30 kilometers of fiber, maybe a little more. From Delft to The Hague, it was 25 kilometers of fiber. So just to give a ballpark of what it's like. But yeah, this is what the Chinese can do. I mean, they extend the range significantly by using satellites. So this is something that we also don't have in Europe yet.
Do you think it will be hard to catch up with other countries if they have better technology? Do you think there's problems in, say, intellectual property or so that they may not share?
That could be. That could be. I would say that in Europe and in the States, I think the playground is somehow leveled because everything is more or less public. The technology, at least the protocols to do that. Maybe the specific technological implementation is not, but the way to do it is somehow known. But then again, in China, we don't know, right? This is something that we don't know for many reasons.
Okay, so that's a good motivation to keep working hard on
One
this.
of the motivations, yes, I would say, yeah.
Excellent. Thanks. That was insightful, I think. Let me ask the same question to ABN AMRO. So Dimitri, what is the motivation for you to work on these projects, and why is it relevant today? Why not just wait for a couple more years when quantum is more mature?
Yeah, well, it's cool, right?
Is that how you sell it to your boss?
No, but you gotta at some point, when you do work, you can also have fun. And if I talk for myself, I think it's extremely cool to work with these kind of technologies, even though it's far-fetched. But we saw within ABN AMRO that by only sitting back and waiting for suppliers to come up with these technologies, it's going to be more expensive when the time comes. And like Victoria said, when you start using it when it's there, you're going to run behind of the companies that are preparing beforehand, that are proactive right now. And some people will tell you it's easy to create a quantum algorithm. It's not. It's going to take years to develop one. It's going to take years to implement one.
Do you have a sort of a feeling for how long that would take? I mean, you've been involved in various IT projects.
So we saw that within Project DisQover, and we have one use case that there's going to be a paper out by QuSoft on that. And the development of this algorithm to, if you look from use case to the paper, take 10 to 12 months. And then we still need to figure out the details on the implementation. But we have some estimates that, writing down this, creating and developing this algorithm from this paper is also going to take another 12 to 18 months. And that's besides all of the things that come into play when you do this at the bank. And then, we don't know what kind of standards or regulations we need to wait for. So that also comes into play. So if you ask me right now, development of an algorithm take 2 to 3 years. Implementation of an algorithm take another 2 to 3 years. So when you start, when the time is there, let's say worst case, you're running 6 years behind of companies that started doing it already and had already in place. Because if you take that time before those 6 years, of course you need to guess when those quantum computers will be there. But suppose you're ready, you can take 6 years of advantage in that. And that can be different for each algorithm, of course. But that's one of the reasons why we did it. And so being proactive. So don't wait, but start now. But also at the same time, showing others why, what kind of advantage you can really take. And hopefully, by doing that, accelerate the ecosystem and more companies to start doing that. So what we also wanted to get out of this was, to have 1 or 2 companies to get interested into quantum. And maybe give
1 or 2 suppliers?
No, 1 or 2 companies like ABN AMRO, so enterprise companies, not suppliers.
Okay.
And we started also, and then maybe giving, 2, 3, 4 external presentations. But that exploded a little bit, right? So I don't know how many presentations I've done in the last 2 years, and I lost count of the companies that are interested. So in that sense, we were really successful in that. So more and more companies got interested into quantum. Unfortunately, Corona crisis did not help in all kinds of investments in innovation, but things are getting better right now. So I think from 2022, things will start moving more and more into this field.
I think I heard something contradictory, because on the one hand you said you want to be ahead of your competition, you want to start sooner than them, but at the same time you're telling other people to also get started.
Yeah, but I challenge them. I know how hard it is to create a quantum algorithm. So I'm challenging them to come up and give me your algorithm and beat me to it. I'm fine with that. In order to do so, we can just help everybody with that. And if you look at certain quantum algorithms, especially in the fields of fraud or anti-money laundering, it's beneficial for all of us, not just for ABN AMRO. But in that sense, if we can bring data from all the banks together, and then we come into the big play that we're looking for is, okay, if we want to use quantum computing and bringing data from, let's say, 3, 4, 5, let's say 20 banks together, how do you do that? How do you transport that data to the quantum computer? And then you come to the end game. I think this is called blind computing. And for blind computing, we need this quantum internet. So that's a big application of that. But suppose we can do that and bring all the data together from all the banks into a single algorithm, detecting anti-money laundering. And so then we can really make a huge step towards that.
Okay, so anti-money laundering is a beautiful case where we have to work together. So it's good for you if your competitors also work on quantum. But what about many things like, let's say, strategic investments or risk assessment? I guess for you, it's also important that you as ABN AMRO are ahead. And I know many other banks are working on quantum. Do you have a sense of how you compare to the competition?
When you start looking internally within the bank, not all departments are really into quantum computing. And the guys doing those risk assessments, doing those multi-column simulations, they really said, okay, nice technology, but we can't use it now. So we're busy with doing what we need to do already. We have all the regulations that we need to follow. So we can't, do this on the side. There's no time for us to do that. So unfortunately, looking at the multi-color simulations, those guys didn't want to cooperate. But on the other side, there's a lot of other financial institutes that are doing that. So there's a lot of papers out already. So you can just take a look at those papers and use them. So, and then we were like, okay, papers are out, let's explore other areas.
So you funded a postdoc to work at QuSoft, and I guess he was involved in these papers. A couple of people from ABN AMRO were also involved.
Yep.
Do you think they will keep that knowledge within ABN AMRO? Will they be able to, for example, turn that paper into a piece of computer code or sort of a working application?
Yeah, well, that's also something we learned from doing this project, and we can't do that. At ABN AMRO, I don't have the people that can translate that paper into a working piece of code.
Not even the people that worked together on the paper?
The people that work together on the paper from QuSoft will be able to do that. Because we defined several levels of skills that people need in order to operate this whole application. And at the lowest level is just, the beginners, where you at least know the difference between a bit and a qubit. And you can explain it depending on, ones and zeros, and then being 1 and 0, so explaining superposition a little bit. But then if you take it to the next level and understanding a little bit more, it's diving a little bit deeper into the math behind quantum gates, and let's say explaining a qubit via a block sphere. So that's the next step. But the step...
These are very basic steps, right? I mean,
those
nowhere
are
near
steps.
A quantum algorithm.
But if you know that, you still can't develop this application. So you need to become an expert. And if you're an expert, you can just put your CV to QuSoft and work here. Because that's the level that you need in order to create this application.
So maybe in the next session, we should talk about, say, your workforce. How do you get a skilled workforce? How can you train your personnel? How can you hire the right people?
Yeah, we're working on this final paper that we're going to put out, where we explain a little bit on that, and also what kind of skill sets you need in more detail. Yeah.
Maybe if I can add something to that, on the part where you said what Dimitri said is a little bit contradictory, right? That we actually we need to activate the environment that we work in versus we want to keep our secrets, right? I think that actually that this is very consistent because on the one hand, of course, we want to have the applications and we want to be the best and we want to, have the best Dutch network. But on the other hand, there is so much to do that we cannot do it just by ourselves. And activating, really creating this ecosystem where everybody is collaborating towards a common goal is crucial at this stage because this technology is still very small, very tiny, very young. And to really bring it to the level where it can be, we need to work together right now. So this is definitely not the stage to say like, oh, I will have this program running on the quantum internet and mine will be the best. We don't know that. We don't even know if we will be able to sustain a quantum connection within the next couple of years. So really at this stage, we need to work together. We need to activate each other. And what Dimitri says, I think is one of the ways to do that actually.
So there's 3 big telecom providers in the Netherlands, and you're working for one of them. Does that mean you're also activating these other companies? Are you talking to them?
I think that eventually that could be the goal, yeah, to really bring the ecosystem in the Netherlands together. So that if we have the staging network, so sort of a model of a network that everybody could use, that could be a common thing to do. Yeah.
Is there perhaps even a need for multiple competitors to sort of put down a quantum internet? Is that maybe something
right now there is not even a need for a quantum internet. So we're not yet, right? But yeah.
It sounds a lot like people that were interviewed in the 90s. They were asked like, would you like to have a mobile phone? And they were like, no, if I'm outside,
exactly,
I don't want to be
right?
called.
It's like when the regular computers were developed, people were like, who will need that? It maybe like 2-3 people will benefit from a big machine in a room, right? But in the end, everybody right now has a computer with them. Yeah. That can be the case for quantum computing as well, hopefully.
So if I ask how many competing quantum internets there should be in the Netherlands, that's sort of still open. We don't know.
That's a very open question. Yeah.
All right.
That's really it. And to elaborate on the ecosystem and being afraid of others, gaining more advantage, it's such a big greenfield. There's so much to explore. I think it's way more important to really activate others as well and work together on this because and also if you just lay back and you wait, fine by me, and if you do it a little bit, also fine. But it's also important to connect to this quantum realm where the people are working in, because you need that. You're gonna need the people that can actually build that stuff for you. And if you're not connected, you're lost in line.
And like you said, the resources for quantum in companies are not big at the moment, right? So you have a small team. I do mostly things by myself, and this is just a reality of how it is because there is just no real need to supply quantum internet or to supply these quantum connections yet.
You need to create the needs yourself.
Maybe not necessarily, because I think that the need is somehow there when we move to stronger and stronger security. For example, there are applications in which this so-called everlasting security offered by quantum key distribution, it will be necessary. But at the same time, we don't have enough workforce yet to make big changes, next week. So this is also one of the reasons why we have to really collaborate and work on this together at the moment.
Excellent. Well, maybe this is a good bridge to a bit of motivation of our speakers and see how motivated their companies are. So I have another poll for you, which I'll launch right now. And my question to you is, how likely is your organization to start a quantum project in the next 3 years? And you can answer, perhaps you're already running quantum projects. Maybe you're very likely to start in the next 3 years. You can say a bit likely, or if you're very pessimistic, you can say unlikely. Maybe your company is maybe there's not many good use cases, or maybe your company is not interested. And I guess there's many scientists here, so I'll also ask you, maybe your research group could in the end use a quantum computer. And so far I see that everyone says we already have running projects. So yeah, that's nice. A very, very specific audience that is already doing these projects. So I'm happy that you're listening here, and maybe I can invite you sometime to also sit here for the next meetup. I'll leave this poll open for a bit, and I want to talk about the outcomes of your projects, right? Because we know what these projects are, we know why you want to have them, but then I'm curious, did you live up to all the expectations? So maybe Victoria, let me ask this question to you first. What do you think of the projects? Were they successful?
So let me refer to the MDI QKD demo because it's the one that we actually already finished. I would say absolutely yes. The reason MDI QKD was so interesting to KPN and to the community in general is because MDI QKD could actually scale and be upgraded in the future to quantum internet. The reason for that is architecture. So what MDI QKD has, like I mentioned before, right? We had the two end nodes, Delta and The Hague, and then we had a central node in the Rijswijk. Well, the idea is that we can also connect other users to the same central node and then scale this up. That creates a sort of a star-shaped network, which is something that is widely used in telecom.
So you want to sort of grow organically.
Organically, exactly. And I would say that the fact that we were able to demonstrate that, but not only show that we're getting a key rate that is not trivial, and we can encrypt something and send it across the network. So that was one excellent part. But maybe more importantly for telecom, we also showed that this connection, this quantum MDI QKD connection, can actually coexist with regular internet traffic, which is hugely important because that means that we don't have to now take shovels and dig up holes and put out new fiber in the ground. We can use the existing fiber for the quantum connection and run them alongside the regular internet.
So do you have sort of the photons of the classical internet and the quantum internet going through them at the same time, or do they take turns or so?
Yes. So actually, we used equipment from Cisco to sort of imitate the regular internet traffic because, of course, you cannot run an experiment like this or a demo on actual fiber that carries out internet traffic. That would be way too risky. But we showed that these signals can be together.
So you were sort of sending noise or random YouTube videos?
Through the fiber? Much, yeah.
Okay.
Yeah. It's like I said, it's way too risky to just use a regular fiber.
All kinds of pictures from cats.
Yes.
Yeah, I get typical internet usage, right?
Yeah.
Exactly.
So you talked about these rates, the key rates, how fast you can generate a secret key, and I guess criticism right now is if you buy a current sort of commercial QKD system, they're very, very slow. It takes a very long time before you can encrypt your data. Can you say something about the sort of rates that you got?
So this is absolutely true. Like if you want to compare the commercial QKD devices that are out there right now to the internet that was in the 90s, that would be about that. Like at the end of 90s, we had internet as fast as QKD can be right now. So this is not very fast.
So how fast was that back in the 90s?
Back in the 90s, that would be around like 50 kilobits per second.
So a dial-up modem speed.
Yeah, like not very fast. No, we're talking about kilobits, not kilobytes. So yeah, that's pretty slow. Also in the So like you said, this is one of the criticisms, but it hugely depends whether you actually need such a high rate, right?
I think at the end of the 90s, the internet was already reasonably successful, right? People were already sending emails and using that to sort of communicate important information. There were websites.
Right, but and the same can actually hold here, that if you don't actually need to run your QKD connection to encrypt, I don't know, a video from YouTube, which is a couple of gigabytes, but you just need to send a smaller file. maybe that's sufficient for your applications, right? Imagine that you're a government facility that wants to communicate with another building, or I don't know, with a military, and you just want to send a short note. Maybe that's enough, right, of a key rate to actually already be usable. And also it depends what kind of encryption you want to use on top of the key that you're getting out of QKD. So one of the most popular examples, I would say, is the one-time pad, where you literally take each bit of the file that you have and you add each bit of the key to that. So naturally you will need the same length of the key compared to your document, right? But if you want to use another post-quantum algorithm, for example, that's also an option. Then you don't really need such high key rates to realize that.
So what do you think is a reasonable key rate to which you need to grow before it becomes commercially interesting?
Yeah, that's a difficult question. I cannot answer this right now because that would be very, very heavily dependent on the application and what are the customer requirements. So right now, I cannot really tell. The faster, the better, of course, but yeah.
And can you say something about, if we just look at the dot on the horizon, how far are we away from having QKD? Let's say maybe every office might want to have at least a QKD connection, or maybe every house, or maybe every phone.
Yeah, so I think that there is a very important point to be made here. And that point is that not everybody will need QKD to secure their communication. And that's just a fact, because QKD requires different devices. It requires different hardware to actually to be able to perform this key distribution, and then it requires extra layers that would actually handle this key exchange. So for this reason, it's going to be costly, and not everybody will want to spend money, or not everybody will need that kind of security. If I'm just connecting to, I don't know, Bol.com, I will not really need everlasting security from my internet connection to shop. So what I'm getting to is that QKD has narrow applications, and these are applications where a lifespan of data is really important. So for example, for health records, for banking, for government communication, military, police. But nevertheless, we still need to do QKD because, like I said, this is the first step towards more sophisticated quantum networks, so what we call the quantum internet. And if we're able to do that, to actually test the quantum key distribution and have it working, we can then upgrade the devices, upgrade the central nodes, and really move on to creating these real quantum links, which is where I believe the things will be exciting, and any user will be able to benefit from that.
Okay, thanks a lot. Maybe if I can ask you a very critical question. Of course, you were very positive about the project. Otherwise, you would not be sitting here, right? That's why we invited you. But if you're very critical, if you're very honest, are there things about the project about which you say, like, man, that didn't go so well?
For the MDI, you mean specifically?
Yeah. I
think that the challenging part was to arrange the locations on KPN's side, because in Corona times, I think that was one of the biggest challenges we had. We were not able to physically go there, so everything had to be arranged remotely, and the communication with the teams always happens online, right? So this was a big challenge, I would say, to arrange everything the way it should be, to prepare the locations for the nodes. But also we had an excellent team, and we had an excellent team from QuTech to perform really this experiment. And in the end, we managed to make everything work. So I'm really happy about that.
Did you in the end miss certain locations that you wanted to use, or what was
No. So we planned to have one node in Delft, so at TU Delft, then one node in The Hague, which was a KPN location, and then in Rijswijk, the central node was also a KPN location.
Okay, so it took a while, but in the end you could.
It took a while, yes, but in the end, all things considered, in these difficult times, I think it's a challenge for everyone to really go and work in the lab.
So how long do you think the project was in the end delayed due to Corona?
Oh, I don't really think it was delayed very much. We can talk about like 1 or 2 months.
That sounds pretty reasonable.
It's reasonable.
So the average PhD is sort of over time.
Yeah.
It's a good excuse for the scientists.
Oh yeah. Well, I mean, it's kind of common, right? That science, in the end, it never works until you discover something revolutionary. Okay, thanks a lot, Victoria. Maybe I can ask you the same question. So what are the outcomes of, in this case, the DisQover project? So I'm sure you'll talk a lot about the positive outcomes, but maybe you can also give us a bit of a critical
negative
view.
ones.
Yeah,
critical ones. And well, working remotely is on these subjects is not the best way to do. So, but on the other hand, I can't explain those algorithms. I can read those papers to a certain extent, and then when I'm at page 2, I mostly don't understand anything anymore. So I had to leave it up to the guys at QuSoft, and they were finding ways to work together. And I think they were able to somehow work also physically together to work on stuff when needed. So that was pretty okay.
Maybe you can say a little bit about what exactly was the deliverable? What exactly was the outcome of the project?
The outcome, and that was also in the beginning very hard to put that into the minds of the scientists, because we started with exploring things and it was no potential, no quantum speed up, no potential.
Oh, so your project didn't have a sort of a destined outcome. You just started looking.
No, it's called DisQover for a reason. To discover stuff and find stuff, but also, and that's what I had to say, especially in the beginning, because we were only finding negative outcomes, but that's also a result. At least what kind of stuff you don't need to explore any further. At least you can narrow your findings and your exploration to the stuff that you can really work on. And that was also something that I wanted to know, to get out of. But explaining that, and saying, okay, guys, so we found 15 no potential algorithms for quantum. Fine. And they were like, why is it fine? It's a negative outcome. No, it's an outcome. So that's what we wanted to get out of that. And also what we want to get out of is how to do that project. And we phrased it and put it into kind of like calling it a disaster recovery plan. But instead of having a disaster, it's the time when the quantum computer is big enough to perform your algorithm, right?
You're sort of counting down till
we call it
the quantum computer breaks.
Yeah, we call it the quantum implementation plan.
Okay.
But you can look at it as kind of having a disaster recovery. When a disaster happens and you don't have a plan, people will start running in circles and all kinds of panic. I don't know what to do. So
are you calling the quantum computer sort of a disaster rather than a roadmap because you don't know exactly when it's going to happen? Just like a disaster.
You don't know exactly when it's going to happen. And if you're unprepared, you run behind. If you're prepared, you can be ready when the time comes. But you also need to kind of like predict when this computer will have the amount of qubits that you need for your algorithm. And you need to know the speed of the quantum functions that this quantum computer will have in order to, have a speed up advantage of your algorithm. To explain it a little bit, because I see you thinking, it's, suppose you have a quantum algorithm that has, an exponential speed up in number of steps that you need for, this algorithm to run compared to the classical. But what if this classical algorithm will take 1 millisecond for each step, and the quantum algorithm will take 2 days for each step? Then in the end, the quantum algorithm might not be faster, or might not be able to do it at all, like the classical. So those kind of things you need to really know in order, to define when you can use this quantum algorithm on a specific quantum computer. So those kind of things were the things that we wanted to get out of this. So what do we need to monitor? What are the benchmarks? What are the thresholds that we need to look at? Quantum volume is one of these benchmarks that is being put out there by IBM, but not because it's IBM, but it's a company with a commercial take. So, it's something that they want to look at, and we want to look at something that's independent, and also independent of what type of quantum computer. So we wanted to get out with these plans, monitoring thresholds, and then how to implement it. But we're still working on details how to really implement this. Also due to, and it's also specific by each use case, what kind of regulatory standardization, and maybe at some points law might need to be changed, for instance.
So I guess you ended up with a report, a piece of text, and I guess that might end up in someone's drawer, right?
Yeah. So we're ending up. 2 papers are being put out of, let's say, with potential speedups of quantum algorithms. I've seen them, don't understand them. I've seen them. I know that they're being reviewed right now. Hopefully they'll be released somewhere end of October, November, maybe. We're working out this paper internally, and we're discussing what we're going to publish externally. So that's those are, let's say, concrete deliverables.
So some of the results you'll just keep for yourself, right? Some will be published, and some will be private intellectual property of ABN AMRO.
We put some time, effort, budget, resources into creating these implementation plans, and we want to help others on that, but we're discussing to what extent we're going to help others, and also because we can give out, let's say, a template, but for each use case, you need to fill in the details, and they will be different for each use case.
So maybe for both of you, Victoria and Dimitri, of course, you're happy about this because you think quantum is great and you have a background in quantum. Does your company or your supervisor, were they happy? Are you going to start a new project, or do you think you will be allowed to do that?
Absolutely. I think that quantum is becoming a bigger part of the security department portfolio, information security department at KPN, and hopefully we will push it forward.
Do you have sort of a roadmap to work towards a quantum internet?
Absolutely. Like I said, we're basing on these 2 pillars. So first of all, we want to realize the quantum key distribution networks that are upgradable. So mostly actually based on MDI QKD. And then when the time comes, really start upgrading that to the quantum internet. But also just testing quantum links at the moment. This is what we're doing, like I said, with QuTech and other partners.
So if you have a roadmap, do they mention any dates, any years?
Well, if it did, I don't think I would be at liberty to say that. But there are plans, and definitely we want to continue developing that, also connecting to other technologies, for example, wireless technology for 5G. And there might be applications where the wireless connection really needs to be secured with QKD, and that one example of that would be health sector, right? If around the hospital, you can imagine you have those 5G towers that really allow the staff to communicate various records. They then need to be secured with as something as great as we can think of.
Okay, that'll be one of the first breakthroughs, hopefully, that we can get.
Hopefully, let's see how it goes.
Excellent. What about you, Dimitri? Does ABN AMRO have a roadmap?
We had a roadmap, but that was really trashed by the coronavirus, because the coronavirus and the pandemic really hit us hard in terms of uncertainty, and banks are not happy with uncertainty. So we're really, holding our breath right now, waiting until the end of the year, beginning of next year. Hopefully, it's all not that bad. So we can start talking internally about follow-up on those projects. Because for me, I'd love to start doing follow-up on those projects, but it's not up to me.
Excellent. I'm looking at some questions that came in through the chat. Let me first take a look at the poll that might still be on. I asked you how likely your organization is to start a quantum project in the next 3 years. And initially, we got everyone who said, we're already working on this. But this has dropped as more people answered this. I guess about 50% of the people say that we already have running projects. But on the other hand, about 29 right now say that they're unlikely. And then there's a 14 and 5% respectively who say very likely or a bit likely. So there's an interesting mix there. Some organizations that are already doing quantum projects, and some that say, well, maybe we'll likely not start in.
I think there are a few banks in there as well.
Oh yeah, and as we know, these are already working hard on quantum, or at least the few initial projects. let me look at a couple of the audience questions that we got. I hope you can answer them quickly because there's many. The first is, are there any jobs available in Quantum today, like at companies? And which are the requirements, like a degree, experience, skill that you look for? Do you want to answer first?
To be honest, I don't know much because I haven't been particularly looking for jobs. But I would say that basic quantum knowledge would be a requirement if somebody wants to really get into the field. But
like a degree in physics,
for example. But it would also strongly depend on what particular area somebody would be interested in. So let me give you an example. If somebody is looking for a job as an physical layer engineer, which means that really working on those quantum connections and really making sure that, for example, devices talk to each other, or we have everything, the fiber is properly cleaned and everything is set up correctly, then I think that a really strong background in quantum communication would be required, perhaps a PhD. But then if we're talking about layers of the network that would manage this connection, everything becomes more and more abstract. And then really background in software engineering would be extremely useful.
The classical
software engineering.
Or like network
engineering. Because then this really strong quantum knowledge is not strictly necessary to be able to have a valuable input into designing these layers. But then again, if we're talking about quantum applications, again, I think that this is something that requires a really strong background.
Okay, so you need many highly skilled people, but at the same time, these jobs are not there yet.
These jobs are not there yet, but there is a whole variety of what people can do. Like Dimitri said, there is a really big playground of quantum, and I think that if somebody has technical skills in, let's say, software engineering, they would be able to find something interesting for themselves.
If you ask me, if someone's asking me what kind of thing do I need to study, go for quantum.
What does it mean, study quantum?
Well, quantum mechanics, quantum physics, quantum computing, there's all kinds of different, let's say, elements to it. And also, think about, if you have those people that are able to do and develop those applications, you will also need people that are able to sell it. So you need also business developers. And in my opinion, also those business developers need to have a certain, level of quantum understanding to this quantum.
Everyone around the quantum group, sort of a layer around the quantum group should have a basic
but also internally, also in the bank. If I have a team of people using a quantum application, and they really don't know what this thing does, how can they signal when something goes wrong? Or how can they signal when an outcome is not correct? So you really need to understand it. And I think, in the coming years, and already right now, I think the people working in quantum technologies are so busy that there's already a shortage. So we really need, and whenever there's a shortage, jump in and go for that study. Because then you'll have a job for life.
Okay, so wait, that contradicts a bit, right? Victoria said there's no jobs at the moment. Well, not many jobs at the moment, but you do expect a job shortage in the near future.
I think already there's more than enough jobs in the fields of quantum technologies, and there'll be way more in the coming years.
Okay, so maybe more focused on the sort of software applications then. That's where...
All kinds of fields, sensing, communications, but those are hardware, computing. There's so many different fields, and it's so hard. Not everybody will be able to do this.
There's an interesting comment from someone who says that there's since recently a job board for quantum jobs available on the website of Quantum Delta NL. So the URL is quantumdelta.nl, or I'm sure you can Google that. And for me in QuSoft, I actually noticed that many people don't even have a physics background. We have many people who study mathematics or computer science. And for them, it was relatively easy to learn at least the basics of quantum that are needed. But if they have a cool background in algorithms, for example, it's okay for them to drop in. maybe let's go to another question, maybe a quick one. So someone asks, are your projects mostly on software applications or also on hardware? And then they say interested to see how this reflects on your team background. I think we have a clear distinction here between ABN AMRO software and KPN mostly hardware.
Mm-hmm.
Can you say something about your team? Are they all hardware specialists? Do you have software people in there too?
Yeah, so maybe when we're talking about hardware, it's important to distinguish, different types of hardware, right? Because we have the end devices, which are basically were brought in by QuTech in our case, but commercially can be bought from ID Quantique, can be bought from Toshiba and other vendors. So these are really specialized companies that only do QKD devices, and you can buy them and stack them on your rack and you're good to go. So this is not something that we would be interested in doing at KPN, to developing this hardware, because simply this is not the objective of KPN. The objective of KPN is to use the fiber architecture and the knowledge about optics to bring quantum to the network, but also bring this knowledge out about optical networks to help design better devices.
Yeah, your service is the network, right?
Exactly, not the actual device. Yeah, exactly.
Excellent. What about you, Dimitri? Do you recognize that your team is all about software?
We're going to build everything ourselves because, we can't. It's about managing your suppliers and finding the right partners to develop that stuff. Looking at certain elements in quantum communications, key management systems, those kind of things are the things that we can do. But outside of that, it's up to the others. In the fields of the applications, the algorithms, our data scientists can, let's say, discuss the data and the data sets and how we transport that into a quantum computer or in a quantum algorithm. But beyond that, we don't have the skills to do that.
So you also mentioned that you're not going to write everything yourself. So I guess an ideal quantum team at a bank, should that be a mix of quantum specialists and perhaps people who can talk to the suppliers?
No, we were lucky to find one guy that actually understands quantum algorithms, and he worked extensively with the guys here at QuSoft. But that's only one out of 80,000 people. And we had some other data scientists that really understand the classical algorithms. And it's them working together and creating this, let's say, full system. Without a supplier like QuSoft, we'll have nothing.
All right, thanks. Maybe a last question about QKD. So that's for you, Victoria. I'm actually getting two. Someone asks, when it comes to QKD networks, is it more important to cover a long distance or to have many connections in a network exchanging keys?
Oh, that's an excellent question. I think it strongly depends on the area that you're trying to cover and the availability of your fiber. So the
distance is the biggest problem.
The distance is, of course, the biggest limitation when it comes to QKD, especially when it comes to on-ground QKD, because we have fiber attenuation and we just lose these quantum signals very fast. So the Netherlands is very densely covered in fiber. So I would say that it would be pretty easy. Okay, but easy here has a very big quotation.
Relatively easy. Yeah.
Relatively easy to do the on-ground QKD. But if we go to, even if we go to the States, they don't have such a very dense fiber architecture in some areas. And then the only way to do that would be actually to use a satellite. Now, whether it's better to have more connections or to have longer connections, I would say when we look at the upgradability for the future, so to really have quantum internet and quantum repeaters, I would say it's better to have more shorter connections. Yes, that would be more useful. Just because if we have more quantum repeaters, which is of course far ahead in the future, then we would be able to connect far away points with entangled links more easily.
All right, thanks a lot. I think we're out of time, so I'm going to end here. I have a couple of important announcements for people who are still watching. Please hang on. And if you're watching live and you're on the Quantum.Amsterdam website, please scroll down, and there you will see a link to our after chat, our little borrel. The link will take you to wonder.me, and that will allow you to chat with us here and ask any remaining questions that you may have, and of course talk to all of the other spectators of today. So I hope you enjoyed this. I also hope that you'll join us for the next session in November. We already talked about workforce, which I think is a driving force to sort of create more leverage for companies. So next time we'll be focused on that in a much bigger meetup, with a much more elaborate program. So please follow us on Meetup or sign up for the newsletter on Quantum.Amsterdam. So that's it for me. Thanks for watching, and I hope to see you at the wonder.me after chat. Goodbye.